Hi, this is Kevin Trainer. I'd like to welcome you to my lecture on Chapter 19 of the Murach MySQL book, second edition. Chapter 19 is entitled How to Backup and Restore a Database. I'm going to leave the objectives for you to read on your own. And I'm gonna give a kind of a word of, I was going to say warning, but maybe more explanation here. The chapter in the textbook is based upon the command line tool. Okay. So there is a MySQL Dump program that's a command line tool. That has a lot of functionality, okay? And so the lecture and the slide set that I have here talks about the functionality of the command line tool. On the other hand, there is functionality in MySQL Workbench that creates a graphical user interface for backups and restores that are really implemented under the covers, at least the backup is, with MySQL Dump. And that's really the user interface that I favor. Now, can you do everything with MySQL Workbench? No, you can't. And that's why it's kind of worthwhile to read the chapter, to listen to the lecture, and all that kind of stuff. But I'm going to demonstrate the usage of Workbench for backups and restores in the next of the videos that I record. And that's probably the method I'm going to want you to prefer. Okay? So covered in the chapter here, a strategy for backing up databases. A typical strategy is to use the MySQL Dump program to regularly create full backups of each database. Enable a binary log to create incremental backups. So these are ideas that you should know. The nice thing about the command line capabilities of MySQL Dump is that you can create a script file that can be run at regular intervals that will do backups for you. Okay? And if you really want to have a completely automated solution, that's probably something that you want to do. All right. And here's a strategy for restoring databases. Use the MySQL program to run the SQL script file for the last full backup. Okay. And then use the MySQL binlog program to execute all statements in the binary log that occurred after the last full backup. Okay, so this is a strategy for restoring your database to the point where it was when the server failed or when your application failed. Okay, and this is a great strategy. So let's look at that. So terms to know here: full backup, incremental backup, point in time recovery. So full backups are just that. They record everything that's in the database. And as we're going to say, it's really typically a full dump of the database. It records the schema. It records all the values in all the tables. It records the whole thing. Okay. So you can turn around and use a full backup to create a new copy of the database on the same server or another server. An incremental backup is just a backup that tries to capture the changes that have happened since the last time you did a full backup. And in terms of the amount of data that it has to record as its output, well, it doesn't have to record quite so much because it's just looking for changes. So there's some savings in terms of the writing of the backup files. The backup files for an incremental backup are pretty typically shorter than full backups. And point-in-time recovery is a concept, okay? And the concept here is the following. How can I get back to a point in time when I had a failure? Okay? So this is a concept that's going to help you in doing your production work, when you're out doing your day job, right? And you have a production system, right? Some combination of all these things we've talked about are going to allow you to recover to some point in time, okay? And typically that's the time right before the failure occurred. Okay, so there's a lot of details within the chapter on using the command line, which is something that I've not been emphasizing in the course, and I'm not really going to begin now. But for instance, here are the command line entries that you would need to change your working directory to the bin directory of MySQL that has these command line programs in it. The one command line program that we're going to talk about the most is MySQL Dump. So some common options, you can ask to dump databases, all databases, single transactions, routines, events, flush logs. There's all kinds of things that you can ask for when you're running the MySQL Dump backup utility program. So here on slide 7, we see the command line entries we would need to run the MySQL Dump program for particular use cases. Okay, so for instance, for a single database, we would give it the give it the name of the program that we're running, the name of the database, and then we would direct the output to a particular file. In this case, the file path and file name ending in .sql, and we're saying that the user is root, and we're saying that there's a password. Okay. In the second example here, we are able to say that we want to dump databases, so we know it's a list, and then we provide the list, and then we can use the output redirection symbol, the greater than, to show the file that it's going to go to. It goes to a .SQL file, a script file again, and then we've got user and password information. And then here you can see you can do all databases, and you've got a similar kind of format. So what you'll see when I do the demo, where I'm going to demo the graphical user interface for this in the Workbench tool, you can see that there's a checklist, and you check the databases that you want. So if you only want one, you'll check one. If you want more than one, you'll check as many as you want. So that's the graphical user interface version of this functionality. And we can ask for some additional options. Single transaction, routines, events, flush logs. Okay, so there are lots of capabilities, even capabilities I believe that are not talked about within our text, but are documented well in the MySQL documentation. For those of you who want to use a command line on the Mac, you typically need to code a dot and slash before the names of the MySQL Dump program to specify that it's in the current directory, the bin directory. So when you run a backup, right, you get a script, okay? And we've already seen this kind of output before in our class when we've done, when we were just doing the design of a database from the modeler in Workbench, and we wanted to forward engineer the database and get a script. We were able to take that model and essentially export it as a script. Okay, and that's what you get here. Now, we've got a bunch of commenting things here and general configuration options here on the first slide. On the second slide, this is a very important point, okay? Whichever way you are creating your backup, you want, if it's a full backup, and that's what we're doing here, you want it to recreate the database, okay? If it doesn't, it already exists, okay? So this create if not exists AP, this has the benefit of recreating the database if it's not there, or just leaving it there if it's already there, okay? And that's just what you want, because you don't want to rely on having left the schema before you run a restore. So you can run, the script that comes out of the backup is a script that you run to run the restore, okay? And you'd like a script that will run equally well if you've already dropped the old schema or you haven't dropped the old schema. And this style gets that job done. Okay, and what they're doing is that they're dropping the tables if they exist before they create the tables. And so by the time you get done, you have dropped each of the tables and recreated each of the tables, and you have completely recreated the database. If they don't exist, if you've already dropped the schema before you run this, it's still going to work, because it's only trying to create a new database if there's not one by that name already. It's only dropping the tables if there are tables by that name already. And then, of course, we've got the creates. Okay, so they just go on and on. Okay, and these are pretty standard things. The scripts that we use to load the databases for each, the ones that come with the textbook. Now there are 3 that come with the textbook: AP, EX, and OM. And then there's one that's a companion set that I distribute that's associated with the textbook called My Guitar Shop. And when you run the script in order to load each of those, the script came from a backup. Okay, so restore and backup are really kind of two sides of the same coin. Okay, when you're doing a backup, when you're doing a full backup like this, you are creating a script that you use for the restore. All you do to restore it is to run that script. And then we've got some more advanced options for the MySQL Dump program. Add drop table, add locks, disable keys, comments, quote names, create options, compact, compress, delete master logs, force. These would be things that you would want to do if they had some impact on the continuing health of your database. So these are things you might want to do every time you do dump. How do you restore the database? Well, if you're going to do it at the command line, you run the command line client, MySQL. Okay? If you're going to do it using Workbench, well, then use the Workbench feature that runs a script. So you open up a connection to the server, and you load that script into the editor, and you run it. Okay? Or at the command line, you can use the syntax that you see here, and we've got the same comment here that you need the / typically on Mac OS X. And here are some common options for the MySQL bin log program. Okay, so bin log is a binary log. This is a change log. Okay, so what this kind of log does is it records the changes from some date and time. Okay. Now, so that, let me be clear. So the binary log is a feature of the server product, okay? And the MySQL bin log command line program can process those server logs, okay? And here's how you typically do it, okay? Let's say you want to get it back to a particular point in time when your server failed or your application failed, okay? Well, then you go back and you find the last dump that you did, right? And you restore it, and then you take the MySQL bin log for the period that started right after you did the last dump, okay? And that stops right before the failure, okay? And what this does is it it's like fast forwarding. It applies the changes that have happened since the last full dump until you get to the end of the changes that you want to apply. So you typically don't want to apply a change that was associated with failure, right? If there's some kind of transaction that started, we didn't get all the way through it, and we blew up, well, we'd probably like to stop the restoration just before that bad stuff went on, okay? And then we go back and we know where our application is. So when using this MySQL bin log to spin forward the changes to the database that have happened since your last backup, again, use this command line program. you point it to the log file. Okay. And you don't have to specify the database because this will do it for all the databases. Okay, so this would be a typical use case for a database administrator who was responsible for recovering the database after a hard failure. Okay, so what would they do? Well, they would go back and they would find the last full backup of all the databases on the server, and they would do a restore. That could take a while. And they would go back and find the log file, and they would play it forward using MySQL bin log until they're caught up to just the point where they want to be. So this would be a way to do it for all the databases. The second example here is how to do it for a particular database, AP. The third one is for a particular time range. So if we use the commands as they're provided in the first two examples here, we're going to apply all of the changes that are in the log. Okay, and typically that's not a problem in that the changes that are part of a failure sequence it typically don't get written to the log until they're done. Okay, so typically we want we're going to get whole transactions written to the log when the work's done. But we can pick just for a specified time range, and it'll go from the start time. We can say the start, and it'll go to the end, or we could say the end, and it would go from the start to the end that we specify, etc. Sometimes it's been so long since the last time you did a backup that you've got more than one binary log file. Okay, here's a case where we've got two, and here's how you concatenate them. Okay. Here are some details about how to run these things on various operating systems. Now, how could you convert a binary log file to an SQL file? Well, you can use the MySQL bin log utility, and as input you give it a binary log, and as output you direct it to a .sql file, and it will do a conversion for you. Now, why would you want to do that? Well, then you could take the statements. What that does is it takes the changes and expresses them as proper SQL statements that you would be able to bring into the editor. You'd say, oh, well, we do want those, we don't want those, so take those out. And you'd say, okay, now run this. So that would be a way to have a lot of control over what changes were applied after you did a restore. Okay, and why is it not kept in that format all the time? Well, it's kind of a it's not compact. Okay, so there's enough information in the binary log file to turn it into SQL. Okay, and it's pretty densely packed data, not user-friendly. Friendly enough for the MySQL bin log program, but not friendly enough for you and I if we're going to want to look at the script and do some edits and pick the parts that we want to run. Okay. So here is an excerpt from a converted file, and as you can see, it looks like the scripts that we've generated using other utility programs. Okay. Now, if in fact you want to play the changes again, it even, for instance, sets the timestamp. Right? So it sets the timestamps, then it does the insert. So it's really trying to recreate what had actually happened before, right down to the timestamps. Pretty cool stuff. Here's a case where somebody has dropped the example database, drop a database EX, and say, oops, we didn't want that to happen. So what did we do? Well, we went back and we converted the binary log file to a script, and we said, okay, we're going to want to play it, but we're going to want to leave out the part where we dropped that database. Okay, so they've highlighted here with the idea that we would delete that before we ran the script. How to use the MySQL program to execute the converted file. It's just a plain old script. Okay, so if you want to execute it with the command line program, which we haven't done a lot of in this course, you can feed that script file as input, see the lesser than sign, to the MySQL command line program. And there's some operating system notes here. As an alternative, if you're a person who works typically with the workbench, then you could open up a connection with the workbench. You could load that script. You could even do some editing of the script to maybe take out the offending commands, and then you could run the script from Workbench like we've been doing for the whole class. Now, this part of the chapter talks about how to export data to a file. Okay, and this isn't particularly for backup and restore. This is maybe for conversions, right? I think the use case is more unique than the backup and restore. But what if we wanted to be able to dump data from some part of our database, and we would want it put into just a pretty usable format? We can say select the column list into out file and then name a file, and then we've got a bunch of options: fields terminated by string, enclosed by a character, escaped by a character, and then apart from that, it's just a plain old select. So we can do a select to get the data out of the database and into a file. So here on slide 23 is an example where we've done a tab delimited file, and then of course we've printed that file so the tabs are resolved into column positions. Okay, so we're selecting all columns from vendor contacts, and we say into out file, and then we've got that. And we've got the file path and file name. And so we get those 3 columns. Each row in the results set is going to be a line. And in this case, the column values are separated by tabs. So it's a tab, it's a delimited file. Not because we asked for it, but because that's the default. Okay. Here on slide number 24, we're doing it slightly differently. We're saying fields terminated by comma and closed by double quote, escape by //. Okay. And so we get the formatting accordingly. And again, why would you do this? Well, you do this if you wanted to dump data out of your application's database. Maybe for transmission to some other application. Maybe for some kind of conversion that you were doing. Okay, now, what if you want to load data into the database, but you don't want to do it one insert at a time? Can you do that? Can you do a batch load? Yeah, you can. And when would you want to do this? Well, when you're doing some kind of conversion on the input side. Let's say that you're trying to populate the data in your database from some data in an older application, and you'd like to load the data in a more batch-oriented way, not a row at a time. The fact is that it'll get added a row at a time anyway, but at least it looks like a little bit less work for you. So we can say load data in file, and then the file path, into table, a table name, and then we have these optional capabilities to control the termination character, the enclosing, and the escaping. So we say load data in file, and then we've got the file path and name into table vendor contacts. Okay. Or if it's a comma delimited file, we would add fields terminated by comma and closed by double quote, escape by double //. Okay. Now we're going to begin to talk about recovering problems in databases. Okay, so this is real database administrator stuff. If you're a typical practitioner, this is maybe not the kind of stuff that you're expected to be good at all by yourself. If you're working with a group of people and you have some support, this might be the kind of problem that you take to the database area. Okay. On the other hand, if you're a sole practitioner like me, and you're stuck having to solve some kind of a problem, you might have to wade in. So being able to see things like this is certainly helpful for people like me who don't have a group to go to in the average use case. So there's a check table statement. So we say check table, and then there's a table list, and there's an option list. So the table list, of course, would be a list of tables. The options are extended, medium, quick, fast, change for upgrade. Now the check table statement only works when the table is running because we're asking it to check the table. Okay, so here's an example on slide number 27 where we ask it to check table vendors, it checks the table, and it's going to give us an OK if it pretty well thinks it's in good shape. Well, how could it be in bad shape? Well, it could be corrupted somehow. The files that underlie the database, just like any of the files on a computer that you've used, they can accidentally become corrupted. Well, how does that happen? Well, sometimes it happens because of a media failure, so it'd be a bad spot on a hard drive. Sometimes it might happen because some kind of more kind of esoteric hardware failure. Maybe your disk drive kind of acted up electronically, and wrote something that it wasn't supposed to write there. I don't know, maybe there were sunspots, maybe there were heavy magnetic fields, the kind of stuff that makes data on our hard drives go kaflooey, right? Well, this can happen to database tables, and this is a way to check for it, okay? Here, in example 2 is a statement that checks multiple tables and views. So we're doing vendors, invoices, terms, invoices outstanding. So it doesn't really differentiate between tables and views. We say check table. We don't have to say check view name. You can just use the view name. As I recall, invoices outstanding is a view. Okay. And here is a statement that uses an option. We want to check vendors and invoices using the fast option. Now, I could read the very little nitty-gritty details of what you got when you use the fast option and tell you, or you could. So I'm going to leave it for you to do. But generally speaking, when you ask for things to be fast, they're not as thorough. Okay, so it might miss some very fine corruption that would have been found if we didn't use the fast option. How to repair a MyISAM table. Okay, now I just want to point out that in our class, because we've been using the defaults for our version of MySQL, we're not using the MyISAM engine for any of our tables. We're using the NODB engine. So this repair table statement, which has a quick version and an extended version, would not really be of help to us. It would be of help to us if we were using the older MyISAM engine. Here, this is going to apply to us more directly. How do we repair an NODB table? And again, I just want to point out, this is a use case where if you're, let's say you're a power user, or let's say you're an ordinary run-of-the-mill developer in a pretty big organization, and you get this kind of problem where you find a table that's corrupted, it's probably a place where you're going to go down and find the database folks, the DBA group, the database gurus, and they're going to help you here. But on the other hand, if you're a sole practitioner like me and you have you're essentially working on your own, well, then you might have to wade into something like this on your own. So what would we do? Well, we would go to a text editor and we'd go to the configuration file for our installation, and we would add one more entry, NODB force recovery equals 4, and we would restart the server, then use the MySQL Dump program to back up the database, remove the variable from the configuration, restart the server, and restore the database to fix the corrupted tables and restore as much data as possible. So that's a way to get around a damaged NODB table. Options for checking tables with MySQL check. This is another one of these command line programs. Extended, medium check, quick, fast, check only change, check for upgrade. Okay, so these are ways to check your tables in a more rigorous way, okay? Because you could run this on maybe all of your databases, okay? And again, what's the difference between the fast or the quick version and the non-quick version? Typically, they're more the quicker they are, the less they do. So they're going to find a quick check is going to find fewer problems than a non-quick check. Okay, so here's some syntax for how to use MySQL check at the command line. We've got it for a single database and multiple databases, for all the databases, specified tables within a database, a quick check, and extended check. Well, what would be an extended check? Well, it would be the opposite of a quick check. It would be even more sensitive than normal to finding problems. Why might you not want to run that all the time? It probably takes longer, right? Options for repairing tables with MySQL check. Well, there's a repair option, an extended option, a quick option. So how would we use MySQL check to repair tables? For a standard repair, MySQL check AP repair. For an extended repair, MySQL check AP repair extended. And again, you can only use this when the server is running because the server controls the database. So what's really interesting about all these command line programs is, given the architecture of MySQL, they're all clients. They're just command line clients. And how are they different from MySQL Workbench? Well, MySQL Workbench is a graphical user interface client, a GUI client, and it has some subset of the capabilities that are in the command line programs. This checking and repairing is not well developed in the Workbench at this point, and what their plans are, I don't know. But they're just really two different kinds of clients. There is another command line client for tables that are implemented with the MyISAM engine. It's called MyISAM check, and it's got an extended check, a medium check, a fast check, a checked only changed, and a force. And how would you use it? Well, again, you're only going to use it on a table that is using the MyISAM engine, which again, for people in this course, probably is not going to be any of our tables because it's not something that we were recommending that you do. But we have the instructions here for a standard check, for a medium check, and for an extended check. And again, the more services you ask for, the longer it's going to take. That's why you might ask for one level of check over another. And of course, with the MyISAM check, you can repair a table. So some of the options: recover, quick, safe recover. And we've got the syntax here for a standard repair, a quick repair, and extended repair. And somehow I got back to slide number 19. I don't know how I managed to do that. That's where I wanted to be, slide number 36. A command that checks the table and repairs if necessary. Okay. So, what did we do here with chapter number 19? Well, we kind of got you ready for backing up and restoring the database, which are things that you're going to do while you're developing your project for the class. Okay. And we really talked through a lot of the concepts of that. We showed you how to do it with the command line tools, although I'm not going to recommend you use the command line tools. What I'm going to recommend that you do is that you use the Workbench graphical user interface, which actually uses those command line tools under the covers. Okay. What other things did we talk about? We talked about the general idea of setting up a backup and restore scheme for your production database. And this is a case where you probably would use the command line tools because you'd want to run backups on some kind of regular basis. And we talked about the idea of being able to take the combination of full backups plus the binary log file, which we're going to talk about when we get into the chapter on checkpoints and such. And you can so you can take the full backup script and restore it, and then you can play the binary log file to get you back to where you were before you had your system failure. Okay, so this isn't probably something you're going to do in this course for your project. That's kind of going to be overkill. Okay, we're going to be able to get what we want to get done with just full backups and full restores. Okay, but it's very nice to understand those capabilities. And last, what we did is we went into some of the features that allow us to diagnose and solve database corruption problems. And again, these are things that most of us who are going to work in large organizations are going to have a person to go to help us to solve that problem. But some of us who are going to be sole practitioners might find ourselves trying to wade through these kind of problems on our own. And so having had a tour of those capabilities puts us a step ahead for those situations where we'll be called into action. So from here, I'm expecting you to go on to the tutorial for doing backups and restores with MySQL Workbench. And I'm going to say goodbye until then. Bye-bye.